On some race engines, the installed height may need to be increased because of very high valve lift. This will, of course, entail machining the spring pockets deeper. As a final measure, to ensure near perfect valve seal, the valves are lightly lapped into their respective seats. After lapping in the valves and thoroughly cleaning all components, especially oilways, the head can be finished, assembled, ready for use. At this, the final assembly, if the head is not to be used for some time, we recommend molybdenum grease, as it won't drain off and has high anti-seize properties. The procedure for assembly is the reverse of the strip down. Use your soft punch to make sure the cotters are seated correctly. With the assembly completed, David Vizard tests our modified head on the Janspeed flow bench. The reading shows a substantial increase in airflow, which will translate into more horsepower.
Basically what we have here is a glorified vacuum cleaner. In essence, this is all a flow bench is. It's a highly instrumented vacuum cleaner which allows us to check to see how efficiently the ports flow. And of course this is all important for the power output of the engine.
For our Phase 1 car, the point has come to start bolting on some performance equipment. At the strip down, we had left the block face cleaned, ready to start assembly, which begins by locating the head gasket on the studs. Here our newly modified head is lowered in place. Push rods are reinstalled in their correct order and the rocker assembly is installed. Rocker angles must be checked and shims used under rocker pillars if necessary. Having made sure all the adjusting screws are located in the respective push rods, lubricate all the studs. The securing nuts are then fitted and torqued down in the correct sequence and to the proper torque value. With the plugs removed to make engine rotation easier, the tappets are set to the correct clearance. After the rocker cover has been installed, attention can be turned to the type of induction and exhaust used. The exhaust manifold being installed here is the one-piece, small-bore, medium-length centre branch item. Apart from being one of the least expensive, this manifold works well on engines up to about 55 to 60 horsepower and complements a single carb installation. Installation of the induction with a high-flow, water-heated manifold is straightforward as all the standard parts still fit. Other power-producing options, such as high-performance air filter assembly, can be used on this setup. You'll need to reroute the heater pipe hoses through the manifold. Nevertheless, here is how our Phase 1 engine in a single carb guise looked when completed. This represents a minimum of 30% power increase. If you want power levels a little above our basic Phase 1, and these may involve the addition of a cam at some later stage, then a long centre branch or LCB exhaust manifold is first choice. This can be used with either a single or twin carb setup. If twins are used, bulkhead clearance is a criteria that must be taken into account. This Janspeed Cooper S replica system can be used with either the standard air filter setup or these more efficient K&N high filtration items, specially made for this application. With the top side more or less completed, the remainder of the exhaust system can be bolted in place, which leaves the engine side of our Phase 1 Mini almost complete. As with any modification program, you should finish with the final settings obtained on a chassis dyno. Meanwhile, in the body shop, the restoration of our Cooper S lookalike Phase 2 car is coming on. The basic shell is now 100% sound. All rusted areas have been replaced with new panels, and the shell is ready for the low-bake spray booth. Prior to the priming, the last vestige of dust is removed with tack cloth. Now the primer is applied. Once dry, the interior surfaces will be painted and the exterior once again flatted with panel cleaner. Here's the final coat on the distinctive white roof. Back with the engine, we look at power production in greater detail. The air filter is an extremely important factor here. It doesn't matter how effective the carburation may be, if airflow is restricted, as is often the case, by the filter, maximum performance will not be realized. Janspeed strongly recommend the desert racing tested K&N units. They, unlike many filters, successfully combine properties of both high flow and filtration. Carburation is an area that has always been a point of argument for many engine building enthusiasts. Contrary to popular belief, large carburetors will not necessarily deliver maximum power. If air demand is satisfied by a certain size, then employing even larger carburetors achieves nothing. For the enthusiast, tuning BL's A-series engines gives the details needed for carburetor selection based, as it should be, on flow capability rather than size. If the intake manifold doesn't allow efficient delivery of the mixture to the engine, maximum potential will not be achieved. An enormous amount of designing and manufacturing goes into exhaust components. They are more than bits of pipe welded together. Each prototype system is dyno and noise tested. Until it meets certain stringent performance criteria, Janspeed manifolds are not released to the public. Independent tests done by David Vizard have shown a well-designed exhaust manifold can improve output up to 17%. Having established that the block for our Phase 2 engine rebuild is sound, it's rebored to accept the new oversized pistons. After boring to about 2/1000ths under the required size, the bores are finish honed to produce not only the correct size, but also the correct finish. Without proper attention to finish, ring seal and life can be seriously hampered. In a high-output engine, it will be necessary to utilize special high-performance pistons, such as produced by DG Race Products and Omega. This can actually contribute significantly to engine output. Many components in an engine can be lightened. A heavy flywheel may make for a smooth idle, but not a responsive engine. Lightening the flywheel or any of the internal components doesn't help static power, but it does help the power available during acceleration. Some crankshafts can be improved and toughened by a process known as tuft riding. All cranks can stand some form of modification, either in terms of lightening, tuft riding, or shot peening. Lightning crankshafts, especially 1275s, can be an expensive business though, and generally only proves cost-effective on engines where the sole intent right from the start is maximum output. Once any lightning has been completed, all the rotating parts must be balanced. This will require the services of a company like Saunders Engineering. The procedure for rotating components is to balance each part independently. That way, parts subsequently changed, so long as they're in balance themselves, will not adversely affect the overall balance. Though any excess weight in the engine can be considered a bad thing, it's especially bad to have excess weight in the connecting rod department. Connecting rods, especially in the bigger engines, have been considerably over-engineered by the factory. Though later rods, such as in the Turbo Metro items, are lighter, most rods preceding that are unnecessarily heavy. Lightening the rods can not only make the engine a little more responsive on the throttle, but also reduce big end and main bearing wear. Connecting rods must not only have the same overall weight, but also be balanced end for end. A simple fixture like this can be used to balance all the big end weights. Having dealt with the big ends, remove metal now from the little ends only. This will achieve the same overall weight whilst keeping the rods in balance end for end. Of all the parts that require balancing, the pistons are the simplest to deal with. Once the heaviest to lightest pistons have been found, metal is removed from the heavier pistons to match the lightest of the set. If your funds are very limited, balancing may seem a luxury to be dispensed with. However, if parts have been lightened, it is essential. With parts of the new motor painted, we can start the assembly. First, check the top of the bores to see that it has a small chamfer for a lead-in when installing rings and pistons. The pressure relief valve, this one has been made adjustable, can now be fitted. Place the main bearing shells in the block and smear them with an engine building lubricant. Then, douse with oil and lower the crank into place. Prepare the main caps, ready for installation. Then insert the thrust bearings, install the main caps and torque up the bolts. The crank should spin freely, as you see here, but professional engine builders will check crank clearances with a dial gauge measuring in thousandths. They will look at end-to-end clearances and then vertical clearances. These must all be within manufacturer's tolerances. It's important to lubricate well at every stage. Making the correct cam selection is crucial for a high-performance engine. Avoid the temptation of selecting a cam which is too racy. For our project car, we made a cam selection based on the latest technology utilizing the high lift, short opening period concept. A Kent Megadyne 266 cam was used, together with Titan 1.5 ratio roller rockers. The short timing gave excellent road manners low down, but the lift, which is higher than race cams of just a few years ago, gave top-end results rivaling some of the milder race cams of that time. All Kent Cam's cam profiling is the result of extensive research and development, using computer-aided design techniques. High-output engines are inevitably driven hard, so putting a greater demand on the lubrication systems. Any new A-series oil pump is more than adequate, but many earlier designs are not. The moral here is always use a new pump. With the oil pump secured, the thrust can now be fitted. This now leaves us in a position to check and set, if necessary, the alignment of the Kent Cam's adjustable cam sprocket. Our next task is the press fitting of the pistons to the rods. This is best left to a professional. A number of methods are used, this is just one. After fitting the pistons should be as free as this. Ring gapping is an important procedure that should not be rushed. Note how rings are set square in the bore with a piston. Best power is achieved with a minimal width ring gap as recommended in the overhaul manual. Before installing the rod and piston assembly, fit rubber sleeves over the bolt threads to prevent nicks to the crank journals. After fitting the bearing shells to the rod and cap, liberally lubricate the rings and piston as well as the crank and bearings. With the relevant crank pin at bottom dead center, install each rod, oil the journal, and fit and torque the rod cap. Turn the engine over to establish the exact top dead center position for subsequent cam timing, then install the studs. Provisionally fit the timing chain so the dots are aligned as you see here, while the piston is still on top dead center on number 1. Check cam end float.